The M16 didn't start as a military project. It started as a business problem for a small aircraft parts company in Southern California called Armalite, and the man who solved that problem was an engineer named Eugene Stoner. Stoner had worked in aviation during World War II, and when he came to Armalite in the mid-1950s, he brought an aircraft engineer's instincts with him. Instead of building a rifle out of milled steel and walnut the way every rifle before it had been built, he built one out of aluminum forgings and a new plastic called fiberglass reinforced nylon. The result was almost absurdly light for a battle rifle. He called it the AR-15, and it fired a small, fast .223 caliber round instead of the heavy .23 caliber round. Instead of the heavy .30 caliber ammunition the U.S. military had used for decades. The idea was that a soldier could carry more ammunition, control the rifle better on automatic fire, and still wound or kill an enemy just as effectively, because a smaller round moving fast enough does plenty of damage. The Army wasn't interested. Army leadership had just finished adopting the M14, a rifle built in the old tradition, chambered in the full-power 7.62mm round, and they weren't eager to reverse course after fighting for years to standardize that weapon across NATO. Armalite, meanwhile, was a small company that didn't have the manufacturing capacity to produce rifles at military scale, even if the Army had said yes. Stoner's design borrowed heavily from principles he'd seen work in aircraft manufacturing, where weight savings mattered as much as strength, and he applied that same thinking to a weapon that had traditionally been judged by how heavy and solid it felt in the hand. That philosophy ran against decades of small arms tradition, where a rifle's weight and wood stock were seen as signs of durability, not drawbacks. So in 1959, after years of trying and failing to interest the Army in adopting the design on Armalite's own limited production capacity, the company sold the design and the manufacturing rights to Colt's Manufacturing Company. Colt had the factories, the sales relationships, and the patience to shop the rifle around to whoever would listen. The Air Force listened. General Curtis LeMay, who ran Strategic Air Command, wanted a lightweight rifle for the airmen guarding missile silos and airfields, not frontline infantry, and the AR-15 fit that need. That's the strange starting point for one of the most produced rifles in history. It wasn't designed for the Army, it wasn't wanted by the Army, and its first real customer wasn't even a ground combat branch. It took a war nobody expected to escalate the way Vietnam did to change that. By the early 1960s, the United States was pouring more troops and more money into Vietnam, and Secretary of Defense Robert McNamara was looking for ways to modernize the military on a budget and on a schedule that didn't match the Army's traditional procurement timeline. McNamara's whiz kids, the group of analysts he'd brought into the Pentagon, looked at the AR-15's performance data and liked what they saw. Field trials in Vietnam, with Army Special Forces and South Vietnamese troops, showed the rifle performing well against the AK-47s used by the Viet Cong and North Vietnamese Army. It was lighter, it let a smaller framed soldier control full auto fire, and it let troops carry more rounds for the same weight. In 1963, McNamara ordered the AR-15 adopted as the M16 and pushed it into mass production for use across the military, not just the Air Force. This is where the story turns from a procurement decision into a genuine crisis. The rifle that had performed well in limited trials was rushed into full-scale issue to hundreds of thousands of troops without the same care that had gone into those earlier tests. Two decisions made during this rush would nearly destroy the rifle's reputation and, more seriously, would cost American soldiers their lives. The first was a change in gunpowder. The rifle had been designed and tested using a specific type of extruded powder, but when Army Ordnance took over procurement, they switched to a different type of powder, a ball powder made by Olin Mathieson, largely because it was already in mass production for other ammunition and cheaper to source in bulk. That powder burned dirtier and produced more fouling than the powder Stoner had designed the rifle around. The second decision was arguably worse. The M16 was issued to troops without chrome-lined chambers, and, for a period, without cleaning kits, because the rifle had been marketed, wrongly, as self-cleaning. It wasn't. In the humid, dust-heavy conditions of Vietnam, an unlined steel chamber corrodes fast, and dirtier powder combined with corrosion is close to the worst possible combination for a rifle's reliability. Troops in the field were about to find that out the hard way, and some of them would not survive finding it out. Through 1966 and into 1967, reports started reaching home about M16s jamming in combat, and they weren't isolated complaints. A survey of over 1,500 troops in 1967 found that roughly 80% had experienced stoppages with their rifles. The core failure was called failure to extract. After firing, the spent brass casing would stick in the corroded, unlined chamber instead of ejecting cleanly, and the only fix in the field was to push a cleaning rod down the muzzle to knock the stuck case loose, which is not something you want to be doing in the middle of a firefight. Letters from Marines and soldiers made their way home, describing rifles that jammed after 10 or 20 rounds, and families started handing those letters to their congressmen. One letter, read aloud on the floor of the House of Representatives by Congressman James Howard, described a Marine who packed extra grenades and a knife because he didn't trust his rifle to keep working. That kind of testimony is hard for Congress to ignore, and in May of 1967, the House Armed Services Committee formed a special subcommittee to investigate, chaired by Congressman Richard Eichord of Missouri. The Eichord Committee held hearings through the summer, sent investigators to Vietnam to look at rifles and talk to troops directly, and by October, delivered a 51-page report that did not spare the Army or Colt. The report found that the switch to ball powder had directly caused the fouling problem, that the lack of a chrome-plated chamber had allowed corrosion that led to extraction failures, and that officials at multiple levels, including some as senior as the Assistant Secretary of Defense, had known the rifles didn't meet acceptance standards and let them go into service anyway. The committee's language was blunt, describing the handling of the program as bordering on criminal negligence. This wasn't a minor procurement scandal. Soldiers had died because a business decision on powder sourcing and a rushed production schedule had turned a promising design into an unreliable weapon in the one environment where reliability mattered most. The fixes the Eichord Committee pushed for were mechanically simple, which made the fact that they'd been skipped in the first place even harder to excuse. Chrome plating was added to the bore and chamber, which stopped the corrosion that had been tearing apart spent cartridge cases. A forward assist was added to the bolt carrier, a small plunger that let a soldier manually seat the bolt if it didn't fully close on its own, something the original design under Stoner hadn't included because he considered it an unnecessary complication, but which the Army wanted as a mechanical safety net. The powder issue took longer to resolve because DuPont had already stopped producing the original extruded powder in the quantities the war required, so instead of switching back entirely, the ball powder formula was adjusted and the rifle's buffer system was redesigned to handle the different burn characteristics. On top of the mechanical changes, training changed too. Troops were issued cleaning kits, taught to actually maintain the rifle instead of trusting the myth that it cleaned itself, and drilled on clearing stoppages quickly under stress. On February 28, 1967, right as the jamming crisis was at its worst, and troop confidence had bottomed out, the improved rifle was standardized as the M16A1. It's a strange piece of timing. The rifle that would go on to define American infantry small arms for the rest of the century was formally adopted at the exact moment its reputation was at its lowest point. Once the fixes were fully fielded and troops had proper cleaning equipment and training, the failure rates dropped substantially, and the M16A1 went on to serve for the remainder of the Vietnam War and well beyond it, eventually replacing the M14 as the standard issue rifle across the entire U.S. military by 1969. What happened after Vietnam is really the story of a design that proved flexible enough to be reworked again and again instead of being thrown out. In the early 1980s, the Marine Corps led an effort to improve the rifle based on lessons from a decade of field use, and the result was the M16A2, adopted in 1983. It added a heavier barrel that handled sustained fire better and was compatible with a new NATO standard 5.56mm round, with improved range and penetration, adjustable rear sights for more precise aiming at distance, a case deflector so left-handed shooters weren't hit in the face by ejected brass, and it replaced full auto fire with a 3-round burst setting, based on the belief that burst fire made ammunition conservation and accuracy easier to enforce than uncontrolled full auto. Later came the M16A4, which added a flat-top receiver with a rail system so units could mount optics, lasers, and other accessories instead of being locked into the rifle's fixed iron sights. And running alongside all of this was the M4 carbine, a shortened, collapsible stock version of the same basic stoner design that became the standard weapon for most U.S. troops by the 2000s, especially useful in the close-quarters fighting of Iraq and Afghanistan, where a shorter weapon made moving through vehicles and buildings far easier. Every one of these variants kept the same basic operating system Stoner designed in the 1950s, a direct impingement gas system, a rotating bolt, and that same light aluminum receiver architecture. 6 decades of combat experience kept refining the details without ever replacing the core idea. Here's where the title of this video actually plays out in the record. Starting not long after Vietnam and continuing for decades, the U.S. military and its allies kept trying to design something to replace the M16 family outright, and every single attempt failed to reach full adoption. In the late 1960s and into the 1970s, the Army pursued the Special Purpose Individual Weapon Program, an ambitious attempt to build a rifle that fired both conventional rounds and small flechette darts for improved hit probability. It never worked reliably enough to field. In the 1980s came the Advanced Combat Rifle Program, which tested exotic designs using duplex rounds, caseless ammunition, and other technology meant to dramatically boost hit rates over a standard rifle. None of the 4 competing designs beat the M16A2 by a wide enough margin to justify replacing an entire military's small arms inventory, and the program was quietly shelved. In the 2000s, the Objective Individual Combat Weapon tried to combine a rifle with an integrated 20mm airburst grenade launcher, a genuinely futuristic idea, but it proved too heavy, too complex, and too expensive, and it was eventually split apart, with the grenade launcher component becoming its own separate, and ultimately also cancelled, program. Then there was the individual carbine competition around 2011, an open contest inviting manufacturers to submit alternatives to the M4 carbine. Multiple serious contenders entered, went through extensive Army testing, and in the end, the Army canceled the program entirely, concluding that no entrant offered a decisive enough improvement to justify the cost of replacing a system already in service with millions of units and decades of spare parts, training infrastructure, and maintenance knowledge built around it. Each of these programs had real engineering behind it and real institutional will to succeed, and each one ran into the same wall. It's extraordinarily hard to justify replacing a rifle platform that already works, that already has a global supply chain, and that soldiers already know how to maintain, unless the replacement is dramatically better rather than just somewhat better. The M16 and its M4 descendant survived not because no one tried to beat them, but because beating them turned out to be far harder than anyone expected when they started trying, back when the rifle's own reputation was still recovering from the jamming scandal that had nearly gotten it canceled in the first place. That's the real arc of this weapon's history. A rifle almost nobody wanted, rushed into a war that exposed its worst flaws at the worst possible cost, fixed under intense public pressure, and then kept alive for another half-century, not by luck, but because every attempt to replace it kept falling short of a bar the rifle itself had already cleared. Eugene Stoner lived long enough to watch most of this play out. He continued designing firearms for other companies after leaving Armalite, and he died in 1997, at a point when the M16 family had already outlasted every program built to replace it, and was still years away from facing the next serious challenger. Today, the direct impingement, rotating bolt system he built in a small California workshop remains the operating heart of the standard rifle carried by most of the United States military and by dozens of allied nations, which makes it one of the longest continuously serving small arms designs of the modern era, sitting alongside the Kalashnikov as one of the 2 rifle families that came to define 20th century warfare.